So here with the PySpark, let's start this. So very first question is what is PySpark? Okay. So Apache Spark is an open source distributed cluster computing model, or you can say platform, which is open source and it is generally used for processing big data in a faster manner. So let's say you have to process data either in batch, either in streaming with any kind of formats like either structure, unstructured, semi-structure you want to process. You have time limitation also, you have to deliver with quality also, and huge amount of data should be processed regardless of any format, any structure. So Apache Spark is the best choice here. This is built for mostly for high speed, ease of use, and offers simplicity, stream analysis, and run virtually anywhere. The main thing is ease of use because if you are a non-programmer also, you can use Spark easily because it is having multiple APIs. And let's say it is having the categorization. Spark core is there, Spark SQL is there, Spark streaming, is even for machine learnings and all. You have libraries available, mlib and all. That is inbuilt and natively you can utilize that without doing lots of codings and all. And if you are good with the database, then Spark SQL is there. You can utilize. And again, for most of the things, it is too much optimized. And in any of the newest release, you go to new release of the Spark and you check. Of course, you will be getting at least a little bit, but you will be getting some differences, some new enhancement, new functionalities are added. They are always trying to make most of the things ready-made available for us. So we are not going to do the code. Let's say you want to do some filtering or joining or putting some where clause and all for where clause, you can do with say, SQL also where you have to do select a star from table name where this is the condition. Even in data frame and RDDs also simply you can put dot where and you can keep the condition there. So easily it is defined in a way that easily without doing lots of coding you can use that. So this is good for either streaming or batch data and virtually we can run anywhere and it can analyze data in real time. It provides faster computation over the big data. If we come to the next point, the fast computation, that means it is faster than previous approaches to work with big data such as MapReduce. If you remember your Hadoop, anything you were doing with the Hive, it was running in backend MapReduce, right? First mapper was starting, then reducer was starting, then it was completing the entire process. What was actually happening in the MapReduce and how it is getting difference between if you are comparing between MapReduce and Spark. So in MapReduce, first mapper was starting. That means this reads the input from source. Then it was completing the map fetch and generating a temporary output. That means again this is writing the output to somewhere, means temporary location. Again when reducer is starting, then reducer needs a input and that input is mapper's output. So that mapper's output become intermediate input and that is going to reducer phase. Then that means reducer again read one time and reducer will be completing its process and again that is writing to some location. If you forget about temporary and in between read and write, for sure it did 4 times, 2 times read and 2 times write, correct? One time read for the mapper, one time read for the reducer, and one time write for the mapper, one time write for the reducer. That means this is taking some time for reading and writing also. Multiple input output operations are there. And because of that multiple input and output operation, of course, this will be slower. So in Spark, this made with default memory computation. Again, it is always not default memory because it depends upon the data volume. But if data is fitable, then it will be always trying to go with the memory level and it will be doing all the computation in memory. So if everything will be happening in memory, then it will be reducing read and write from mapper. What was happening with mapper and reducer? So a minimum 4 times read write got reduced. That means that much faster it will be getting for sure. If we forget about remaining things, again remaining things also coming in the picture. And the main feature of Apache Spark is in-memory cluster computing that enhances the processing speed of an application. The same thing, input output, reducing the input output operation, and it can be used for multiple things like running distributed SQL, creating data pipelines, ingesting data into a database, running machine learning algorithms, working with graphs or data streams, and many more. Multiple things are there which we are going to work with the Spark U, and it is rich with the libraries where whatever sources you can think you can integrate, whatever targets you can think you can integrate. Let's suppose you have developed a Spark program with your not on-premise model. Let's assume that in your local system, in your laptop, you developed one model, one application, and that is kind of generic one. Generic means this is taking some configuration values at the runtime. This requires that, which you are providing with the Spark submit at the runtime. Same code without any changes you can run with the Hadoop. Even if you are running with Azure, AWS, or GCP, you can run to their platform by putting the same Spark submit command without making any of the changes. That will be helping out. So it is good to run anywhere. It is very much flexible and you can connect with any of the sources. You can connect with any of the targets. It is very much rich with the libraries. Lots of library supports are there. If you can think, I don't think that maybe I am not saying that 100%. Some libraries will be there which are already in progress or maybe that is under consideration. Team is working over there. But as of now, what I have seen, if I can think about something that I am going to do with the Spark, that is available with the Spark. That means we can work with that. So that things are there. Then we are coming to PySpark. If we forget about Python, then we had Java, we have Scala, we have another programming languages, we have R, right? So Spark is simply a distributed processing platform which we are using to process the large amount of data, good amount of data in a faster manner with speed, with some flexibility, lots of optimizations, lots of ready-made functions, lots of API supports and all, which is making it better than any older model comparing like MapReduce or you can compare with any other. Because as this is working in distributed model, you are good to process even GB, TB or petabytes of data. Again, this is flexible with the resources and all. Anytime you can reduce or you can increase the size of nodes, size of cluster. So it will not be having any issue. Coming to PySpark. So PySpark is the Python API support. Previous to Spark is natively developed with the Scala. Okay. And the Scala, you can say the siblings model of Java. That means first Java is there. Motivation taking means motivated with the Java, I can say simply. Scala is there. Scala is completely functional and object-oriented programming language, and Spark is inbuilt with that. If you are doing anything with Scala, that will be too much easy. If you have understanding, if you don't have, then don't worry about that. And it is working internally with that, but it is having support with Python as well, Python API, and you can do the same with PySpark. Some things are there, some things are missing with PySpark. One thing is dataset. Like in Spark, we have three main core pillars, I can say. Like we have RDD, datasets, and DataFrame. In Java, all three supports. In Scala, also all three supports. And in Python, dataset is not there. Only you have RDD and DataFrame. Because datasets, whatever functionalities are there, that has been added with the data frame itself. So additionally, you are not going to work with datasets. Fine. So this PySpark is a Python API support for Spark. Uh, with the help of this library, we can easily integrate with PySpark and we can work with whatever you are thinking about to do with another languages. You can work with this. And again, here I have mentioned that this is the demanding tool among the data engineer. Of course, yes, out of 10, if we talk about recent openings, out of 10, 6 to 7 will be with PySpark. People are looking for the programming any of the language where you are good, and PySpark is in demand because varieties of tasks are there. Let's say today you are working with the data processing, building data pipeline and all. Tomorrow in the same team, in the same project, maybe your requirement can be related to some GenAI, OpenAI and the GenAI, machine learning, some data science, some different kind of requirements can come to you. And that is really very much flexible and easy with Python, PySpark. But again, if we look over the openings right now in the market, out of 10, I will say that still 2 to 3 companies are there who are looking with Java. For example, let's say you are going with Visa, you are going with JP Morgan Chase, you are going with some others. They are looking for Java resources. I will not say for 100% project because any of the project is not having a single, any of the company is not having a single project. They are having lots of project. Maybe some projects are running with Java, some are running with R, some are running with Python, Scala and all. But majority, they are having some majority and they are looking for that skill set. If you look on Scala, then Scala also, most of the companies are there who are working with Scala and they are doing good. Let's say, for example, I can say we have Citibank. I see some projects are running there. With this Commonwealth Bank, they are also using Scala. And like that, I have 20 plus examples. Just what I am seeing right now, they are using that. So we can't say that this is in more demand and this is not in demand. Of course, PySpark is too much flexible and too much easy if you are comparing with any of the language. That's why this is in demand, and mostly this is in demand for its rich libraries supporting all the things. Anyways, supporting all the things means that can be supported in Scala also, Java also. But if you are a learner, this is the main point. If you already know the programming language, then you are good with Java also. You can learn that, you can do the exercises, you can do the projects, you can do, even if you are good in Java, then you will not struggle to migrate with uh, Scala. Java and Scala almost similar. Of course, syntax wise, Scala is too much better than Java comparing to Java. And again, it's functional, so lots of things are there which is not available in Java. You will be feeling too much better if you're working with that. But if you are a learner, then Python is better one because Python is having too much simplicity, less coding, and even if we talk about a data type. In Java, you have to provide the data type. If you do a mistake, you are going to do lots of wrong things. In Scala, this is optional. Either you can or you can't. In some of the cases, you are looking for the specific return type. You are going to provide that. In Python, also same. You can provide the data type, not a thing that you are not going to do. But it is kind of dynamically typecasting. If you are not providing automatically, this is going to pick up, and lots of things this is doing internally for you. So if you are a learner and you do not have any programming background, then Python is the best choice. This is simple. And trust me, if you are really new, then do 10 to 20 small POCs, small codes. And from 21st, you will be feeling comfortable. You will be thinking that, okay, I know Python. I am good with this and I can do that. So this is the case. This is going to help you. Because of that, most of the companies are adopting Python with Spark because they will be getting lots of resources also with PySpark. That will be making flexible for them. And again, their work is also going to be more productive. And then why PySpark? So it is the same. Like large amount of data is getting generated online and offline both, and this data contains the hidden patterns, unknown correction, market trends, customer preferences, and other useful business models which you need to do because data we are getting raw data, and raw data every day data is getting generated in terabytes and petabytes, and we have to process that. And main thing is time. Let's say you got 1 terabyte of data and you have to process. You have two options now. Either you process this 1 terabyte of data, how you are processing, when you are processing doesn't matter. Then even you can do with traditional model also. No one is stopping you. But if that is coming with restriction that this 1 terabyte of data should be processed in next 3 hours, then what to do? You are unable to process with traditional model. Then you have to come here, and as you have raw data, and also if raw data, that means you have lots of things to do. You have to clean the data, you have to correct the data, you have to make that data in a manner where it can be meaningful data from which you can have a good insights, you can extract the information whatever you are looking for, and then you can go with your implementation. So that is going to help. And then we require more efficient tools to process different types of data, because in big data you are not having a single kind of data which you are going to. Data can be either structure, unstructure, and semi-structure. And again, data formats can be different. It can be either XML, JSON, CSV, TSV, Parquet, RC, ORC, Avro. Multiple models are there. Anything can be in your bucket, and you have to process that. So processing with any of the format, any of the model, any of the amount, with any required time. If this much requirement is coming to you, then you are going to work with Spark. And again, if you are working with Python, then you are going to make your work more productive, more flexible. So this is in the picture mostly to making your task scalable and flexible. Okay, then we have some key features in PySpark. Out of that, one is real-time computation. We had MapReduce previously before Spark came in the picture, which was running with on-premise Hadoop site. MapReduce supports only batch. It doesn't support real-time computation. So nowadays we have lots of requirement, either near real-time computation or real-time computation, that we can do with Spark only. Let's say if you go to any of the company's example, you can take up uh, where either you need to immediate response, or your response if it is taking some 1 second, 2 seconds, or 5 seconds, that is okay. But if you are too late, then that is going to impact your business. Let's say if you can take the example of any of the financial, commercial, e-commerce and all, where if you are going for their product, then you just imagine how quickly they are working. You are doing one thing, then simply they are putting some things to your bucket. You just try to buy something similar product, they will be started moving around you, that this is the product you can buy, and someone bought this product with this product, like that they will started recommending the product. Now you see the timing, what how much time they took for the recommendation. Maybe it will be 1 second, 2 second, or hardly 5 second, but not more than that, right? As soon as you click over the product, immediately recommendations are coming, and that recommendations will be similar product, kind of similar product, which can be bought together. So they are that much faster. You have to work with the same speed. If you are not working with the same speed, then your model is going to fail, because this is very competitive market nowadays. Everyone is in the competition, and everyone is trying to be the best. So have to be on the right path. Then support multiple language. PySpark is having flexibility to go with either Scala, Java, Python, and all. So it has compatibility, which making it preferable framework to processing huge data set. Because in any language, if you are good, you can go with that. Even if you are good with SQL, also you can go with that. Then caching and disk consistency. It provides powerful caching with either with the memory or disk consistency, and that is making the work faster. Anyways, we are going to discuss in detail in later sessions. Then swift processing. PySpark allows us to achieve a high data processing speed, which about 100 times faster in memory and 10 times faster over the disk. And if you compare with the MapReduce, our existing model, it is, I can say, more than 100 times faster and works well with RDD. As I said, Spark is having three main parts. One is RDD, one is a data frame, and one is dataset. That is the internal structure of data model we are going to work. But RDD is the core. If you are not doing anything, by default, this is RDD only. So Python programming language is dynamically typed, which helps when we are working with RDD. And we will be, anyways, we are going to discuss that in the later session. Here, if we talk about a real-time usage of the Spark, then you have entertainment industry, commercial sector, healthcare, trades and e-commerce, tourism industry, and all. If we take the example of any of the banking and finance, then not only banking and finance, in any you can see nowadays lots of spammers are there, right? Lots of frauds are happening, and kind of wrong things wrong so how companies are detecting the wrong activity, how they are analyzing if that is the fraud one or it is the genuine, so that is coming under fraud detection. This is most more in the banking and financial one, where fraud detection is in high demand. How they are doing with this these models only, these engine, these softwares processing models and all, but how much faster they have to be. Let's say someone is trying to access your account. Company is means your model, whatever you have built up for fraud detection, that should be good to catch up within few seconds, right? If you are not catching within few seconds immediately, then till you understand what happened, they will be taken up all your money and all. So it has to be faster. So if it is immediately good to detect that this is the fraud activity, they can either block or they can restrict to getting login and all. Okay. So in real time, lots of use cases are there. Here, if I come to this, you can see we have in memory computation a lazy evaluation, fault tolerant, immutability, partitioning, persistence, and coarse grained operations. Multiple things are there, and we will be discussing one by one about all. Fine. Anyone has anything till now?
No, no.
Okay. So here I have documented this all the things for the PySpark, where you can see that this is the definition of PySpark, and currently we are working with 3.5. This is the recent version. Maybe in future it can be 3.68 and 4. Course, this is going to be language wise either with Java or Spark with PySpark. PySpark with R as well. R is also very popular with the Spark. You can work with that. If you have idea, if you're not having, then not an issue. Even you can plan for learning if you are planning for that. Then features of PySpark. As we seen with the previous slides, in-memory computation in the sense whatever we are going to do, that will be processing within memory. But again, 100% not only in memory because it depends over the data. Let's say you are working with 1 terabyte of data and you are having some 10 nodes where you have allocated some 10 GB or 20 GB memory to each. Do you think that your 10 GB, 20 GB memory, your 1 terabyte of data will be processed? What is your thought here? It will work?
I think it will partition now.
My question is, you have around 1 terabyte of data and you have Spark resources available with you for let's say 10 node cluster, and each node is having some 20 GB allocation.
Okay.
Okay. Will it be good to process within memory computation?
No, it will take lots of time.
It will take lots of time or it will fail.
Yeah, if you don't fit it properly, then it will fail.
Okay. Yeah, because 1 terabyte is we are matching with your 20 GB, right? Even if you are coming with you have 10 node cluster, then it is going to be 200 GB, correct? You need more.
Yes.
So in that case, that is going to fail. And even if you are good to manage with the batches, it will be working fine without any failure. But if you think that all the things, the entire 1 terabyte of data is going to work within memory computation, no, that will not be working. So in memory computation is there in a Spark by default, that is by default um, model, but condition is it should be fitable to memory. Otherwise, this will be trying to persist the same data with the disk. Like memory and disk, we have a different persistence level. So this will be going with that. Then distributed processing using parallelize. We are using parallelism for processing the data, and that's why this is faster. Okay. Let's say you are having 1 terabyte of data and you are alone processing 1 terabyte of data. Of course, this is going to take time. If you have 10 node cluster and let's say that one node is having, you are allocating 5 cores to each one, then you are having, if you have 10 node cluster and 5 cores, that means you are having 50 resources. 50 work 50 resources you can utilize for processing, and in that case you can parallelize. So instead of processing with a single model of uh, processing, you can, if you are using a 50 parallelism, 50 parallelized model, of course your work will be 50 times faster. So this is working with that. One is distribution, and second using parallelize, this is going to work with the distributed model and can be used with many cluster managers. You have options. Even inbuilt, you have Spark, you have Yarn, you have Mesos, you have Kubernetes. You can have multiple. Yarn is the famous one, as per my understanding. Maybe in your project something else is in use. So Yarn is the one I can say out of 10, almost 8 projects are running with the Yarn cluster manager. And nowadays, Kubernetes is also in too much demand. Most of the projects are running containerized based, right, with the Docker and the Kubernetes. So deployment is going with that as well. So that resource model is going to be used. Anyone's project is having a Kubernetes containerized based deployment? No. Silence. That means no. Okay. Then fault tolerant. Fault tolerant means how it recovers the data. The thing is, in Hadoop, we had 3 replica. How this is getting distributed with the data nodes, then rack awareness that if uh, any other replica is going to be failed, then how it will be getting recovered from the second copy of the data. So that was working for the fault tolerant. Then it was maintaining the checkpoint pointing details as well with the name node, so it can get managed. Here, it is also working with the same model internally with differences, how it is going to be handle the fault tolerant, how your RDD will be good to recover the data, recompute the data. If you are having 10 transformation and in between one transformation didn't work properly or data got lost in some of the situation, then how data will get recovered. So this is Spark is working with that fault tolerant model as well. This is immutable. Immutable, I guess you have understanding. uh, Immutable means you can't change once it is initialized. So either you are working with RDDs or data frame or data set. Once you have initialized that, then that will be static. And if you are trying to do some manipulation on top of that, then it will be returning a new one instead of modifying the existing one. So this will be immutable in nature. And lazy evaluation. Lazy evaluation is the main thing of Spark. That is the main better thing I can say. And in lazy evaluation, it is something that whatever you are giving it, it will be adopting and it will not fail immediately until unless you are calling it in the real time. Like maybe you have seen some kind of employees. Let me go to the real example. You were saying do this, people will never say no. They will say yes, I will do. Do this again, I will do. And do this again, the response will be I will do. Even you see that means sometimes you say impossible thing which is not doable. For that also they will say yes, I will do it. What is this? Later, when you ask for the report, then they will be coming up with lots of excuses and real problems. What the problem they face, and this is the reason they were not able to do it. But in the beginning phase, they will not say that it's not doable and this will not be done. I'm not talking about 100%. I am talking about few. Some are there who will be immediately responding, no, this is not doable and can't do. But some are there who will be looking for trying up. Okay, let's try this. Like that, this is the lazy evaluation. Let's say you are having 1 terabyte of data and you have only one node cluster. One node cluster in the sense, let's say your laptop only. You are having few GB in the RAM and a few GB with the hard disk, right? Let's take 1 terabyte of data file and try to read in the Spark. Spark will not fail. Even this is not having capacity of 1 terabyte, but this is not going to fail. Then you apply some transformation over there. Again, this will not fail. When this will fail, when you will try to open the file, that means whatever we do, it takes the references, but it doesn't really work with that. You are saying, okay, this is the file abc.csv, this is 1 terabyte. Read the file from this location. Then Spark will be accepting your command. This is just holding the reference that, okay, this is the file location, this is the file name I have to read. Whenever you looking for the output, I will read file from this location and I will be providing the output. Spark catch up that. Then you are saying, okay, do this filter. Again, this will be taking up the reference. Okay, when you are asking, I will filter this condition. Again, you are saying do join. It will again take the references, but actually neither this is going to the location. This is reading the file, not opening the file, not filtering the data, not joining the data. It did not did anything. It just took the references. Later on, you fired one of the action because now you are trying to read the data and do whatever you wanted to. This is the time when Spark will get failed. It will say out of memory exception because this is not having 1 terabyte of memory. But this failed at the last step with the action whenever you are calling for the action. Otherwise, this did not fail. This is holding all the references. So this is for the transformation layer. If you are keeping lots of transformations and all, and everyone needs some amount of data, some amount of reserve memory in the backend. For each up for each and all, it is not going to hold the memory and references and all. This is just going to have the details, reference details, whatever you have provided with the transformation. This will be working with the lazy evaluation without calling the immediate actions over there. And whenever you are trying for any of the action, then this will be starting from the phases, phase 1, phase 2, phase 3. And whenever this is not possible, this will fail with any of the error. Let's say you are doing syntax error. Syntax error will be getting failed, but your logic is wrong. If your logic is wrong but no syntax error, this will be also coming with the lazy evaluation itself because this will also fail whenever you are trying to do that. Okay. I hope that you have understanding with syntax error and some other errors, right? Some exceptions and all. Exceptions will be coming when this is actually working with the data with your model, whatever implementation you have did, if that is doable or not doable. Let's say array out of index. So array out of index will be coming only when you are it is actually trying to access that list or array, whatever you are trying. Then it will be coming up with the memory if file not found. So if you are saying file not found to the location, you are giving the location, that is not the syntax error, that is something missing. Your location is not missing, but your whatever location you are providing, syntactically it is good. So this is not going to fail with the error. That will be failing with the exception, and it will be lastly saying, okay, file not found to this location. Then you are going to take care of what happens in the backend. Then cache and persistence. This is something related to memory and main optimization model also you can say how this is working. So this is Spark is having an inbuilt model for the persistence, how this is going to persist the data and caching the data. Caching the data, so let's say you have some data and you are going to process with the data with some steps, and later you do not need that data, then you can plan that okay, I will cache this data from this step to this step. After that I will do uncaching, means unpersisting. So you can unpersist the data and it will be free up your memory. So caching and persisting is supporting a lot while working with this Spark to make your job faster, and again managing with a huge amount of data. Like you have 1 terabyte of data and this is not fitable to memory, you are and even whatever resources you have available, that is also not supporting. In that case you can plan okay, this much data I need. First of all, you can plan for the batch because at a single run, you can't process with limited resources of memory if you have huge amount of data. And if that is fitable, let's say it is not a 1 terabyte, this is 10 GB, 20 GB only. But in that case also this is not fitable to memory, then you can plan okay. If you at any case, whichever transformation is having less data, like 1 GB, 2 GB, let's process. And if not fitable, then do the persistence with the disk, that will be helping you. So this caching and persisting is going to help you for making the processing too much faster. Caching will be working with in memory and persistence will be working with in memory plus disk. Both of the conditions will be there with some additional serialization and deserialization. Then inbuilt optimizations when using the data frames. Spark is coming with lots of optimizations, lots of functions. Functions are developed. Let's say some functions are already developed for filtering. You write your own filter and you use the filter developed by Spark. Spark one will be more faster because that is optimized, and whatever you are writing maybe that can be optimized also. If you are a good developer, you are taking care of each and everything, and maybe that is not too much optimized. So in that case you have to take care of that. So if you are using any inbuilt functions, that will be always faster and it will be always better. So in our development, we should always care to take the inbuilt APIs, inbuilt model functions and all, if possible. If not possible, then of course we have UDF, user defined function. You can develop your own, you can register the UDF and you can work with that. Then supports MCSQL. If you are good with the database development, good with database query, you can work with SQL model also, and you can do a great job. I think I can say that you can do almost all the things with SQL. Now, as you know, one question can be there in the interview. Let's say what is a Spark? This question will not be coming because they are going to interview you for a Spark only. But one question can be why is Spark? So if question is coming why is Spark, then you have to tell the actual thing. Why Spark is required and why this came into the picture. Why we are using this. Why we are using this means that there was something which was not more better, right? And we were facing lots of issue, and because of that, we migrated to Spark. So here we Spark. I can say this is the next version, next phase of MapReduce, which is optimized. What problems we faced in the MapReduce, Spark came by resolving those. Okay. So one is processing model. In MapReduce, two stage map and reduce are there. And as I said previously, it is doing minimum 4 times, 2 times read and 2 times write, 4 times read write input output operations, because map is having read then write the intermediate means temporary. Again, reducer is going to read that intermediate and writing the final data to disk, final output to disk. So this is having two stage, and that's the reason this will be slower. Apache Spark is having DAG model, supports in memory and computing for faster processing. Because if that is working with in memory, then this is going to avoid this two stage read and write. Then speed and performance. This is slower due to disk input output operations for the intermediate data. And Apache Spark is faster because this is not going to do the same what it was doing with MapReduce, and this is going to reduce the disk input and output operations. Then ease of use. MapReduce was really very complex. In initial days when we were working, means I had started that time MapReduce was there in the market, and we were used to write that. In that case, we had to write Java code, complete Java, uh, using core Java, and there was a mapper class, then there will be the reducer class, there can be some other supporting classes, and then there will be the driver class which is going to call all the functions and all. So Java means again this will be complex. So this was completely complex. Low level programming in Java. If you are good in Java, then only you could have worked with MapReduce. Otherwise, you are going to struggle with this. In Spark, this is completely user friendly. If you are good with SQL, you can work. If you are knowing any of the language, you can work. Even if you don't know, then Spark is having some APIs. Simply you can work without any programming, without any SQL. Like spark.read.option. You are having the option. You want to read the CSV, JSON, Parquet, Excel, whatever you can do. You are having ready-made function with the join, filter, where clause, case statement, everything. So most of the things are coming without development because this is already developed. So it is user friendly with high level APIs in the Java, Scala, Python and all. If you're good with any, you can go with that. Then fault tolerant. For fault tolerant, MapReduce uses data replication and re-execution from the disk on failure. If in any condition, if any failure happened, then this is going to execute from the disk. And for RDD, RDD data from data sets and all in the Apache Spark, this uses RDDs with lineage information to recompute lost data. We will be discussing about lineage and DAG models and all, so don't worry about that and don't be confused. Then data processing. For MapReduce, primarily for batch processing. If you have any requirement with the real time or near real time data, MapReduce was not supporting. And in Spark, it is supporting all kind of processing. Either you are looking for batch, real time or near real time or whatever. Then ecosystem and libraries. This MapReduce is a part of Hadoop and requires additional tools like Hive or any of the higher level functions. And here with this Spark, this is integrated already with the lots of libraries, lots of models, including your Spark SQL, MLib for machine learning, GraphX for Graph API, and Spark streaming and all. Then for the resource management runs on Hadoop yarn. Again, this is flexible. This is not the mandatory one. This can be replaced. And in Spark, it can run on either with yarn, Mesos, and standalone mode. It is up to you. Then use case. Use case, this is large scale batch processing. If you have that kind of requirement, kind of ETL jobs and all, this is the better one. And this Spark is suitable for a wide range of tasks, including real-time analytics and machine learning. Okay, so you can have question. Why PySpark? Why PySpark means you have to say very much clearly what is the benefits of using PySpark. PySpark means a Spark. Okay, PySpark just because we are working with Python, and then uh, how it is faster means why we are using it. Why we are using means indirectly question is coming to compare it with MapReduce, any of the previous model. Previous model was MapReduce only, and using that using the comparison, you can say what was the drawback with MapReduce and what is the advantage you are going to get in the Spark and what is making uh, it great to process the large amount of data with limited time, with any of the structure, any of the format, and all, with lots of optimizations again. Because MapReduce was a low level API and you are going to write the Java code. So whenever you are doing the development, you are taking care for all of the optimization. If you are doing wrong, if you are not handling, this will be issue. You are going to struggle with the data and all. Processing timings will be higher. And then Spark already it is coming with optimization. So this is going to make your job faster. Then advantage. So this one you can mention if this question is coming to you. Spark is a general purpose in-memory, fault-tolerant, and distributed processing engine that allow you to process data efficiently in a distributed fashion. And application running on Spark are 10 times faster than any other traditional system. Uh, 10 times faster, this is because of parallelism. Because in traditional model, you have a single cluster, single server machine, and you are not going to work in the distributed model and with the parallelization, and that's why that will be slower and this your Spark will be faster. And then you will be getting a great benefit from using Spark for the data ingestion pipelines. For building the data pipelines, Spark is in demand. I can say lots of other tech stacks are also there, which are good to build up the data pipeline. But the Spark is booming here because it is having lots of flexibility that along with building the data pipeline, additionally you can do lots of things. Let's say data quality. Anyone has worked with data quality? Data quality check.
Yes, liquid checks we implemented few of there in few of the projects.
Using any tools or just scriptings?
Right now using Scoot tools, but previously Python scripts we were using pandas. But the data volume was not that huge, that's why we not need to use Spark.
Okay. No issue. So the thing is, whenever you are building the data pipeline, you can have the requirement. Means this is the real time requirement I have seen in many of the companies. Let's say data is coming from the source. You have two things now. One thing is whatever data is coming from the source, let's pick up the data, build the data pipeline, and during processing, take care of the data. Either you have to filter, or you have to reject, or you have to check the data quality, or process the data completely, and after processing check the quality, either it was good or it is having any of the issue. Two things are there. And in most of the company, at the very first layer, they are just putting the means dumping the data to the staging layer, a raw layer you can say. And once the data is dumped, then before processing the data from their pipeline, they are trying to have some checks, data quality checks. If data is perfect, then only data will be moved out for processing. If data is not okay, then they will be sending the notification and they are not going to waste the time, resources, each and everything, right? Suppose data is bad. Unnecessarily you put the effort, you are putting the time, resources and everything. So that is not going to work. Or maybe let's say you are getting the data and out of 100%, some 20% data is a kind of rejection. It is not good. Again, you can report that, okay, out of this many data is not coming properly, and you can do the filtration and then you can move ahead with proper reporting. Everyone knows about what you are going to process, what is the data and all. So in with this Spark, let's say you are building the data pipeline, you are not only building the data pipeline, you are taking care for much and more thing. Even you can uh, do some filtration, some aggregation, some data quality checks, some other kind of logics you can implement. So lots of things are happening with the data pipeline. Not only you are just simply reading and writing the data, in between lots of things are there, and that we can have good support with PySpark, with the Spark model. And then using Spark, we can process data from Hadoop, HDFS, AWS, S3, Databricks, Azure, Google Cloud, GCP, and maybe some other platforms. Again, cloud is not limited to these three only, right? Oracle is having its own cloud, VMware is having its own VMware Cloud. Many of the companies are there who are having their own system. So this is not limited to. We can work with any. Then Spark also used to process real-time data using streaming and Kafka. Kafka is having its own streaming model, and Spark is also having its own streaming model. If you are not dependent with Kafka, it is having Spark streaming, structured streaming, and all. You can take the direct support. And then Using Spark streaming, we can also stream files from file systems and also stream from the sockets. You have the options. And Spark natively has machine learning and graph libraries support. So if you have this kind of requirement, you are not going to take lots of additional steps. You can avoid that because library is already inbuilt with this. You can simply import and you can started working with this. And it provides connectors to store the data in NoSQL database like MongoDB, any of the other NoSQL, and some other models, tech stacks. You can do that. Okay, so this is just the intro part where you have to be sure with the understanding what is Spark. And if it is coming to PySpark, then this is Spark only combination with Python, which you can do with Java also, you can do with Scala also, you can do with R also, not an issue. And then why we are using Spark? Because of its faster processing model, lots of optimizations and all inbuilt optimization. And then uh, why it is better, why it is more preferable comparing to any other model, so that you can take a look for MapReduce one. Why MapReduce was lacking, what were the issue with that, and how this is overcoming from those challenges, how this is helping you. In your interview, mostly hardly two questions can be there from this part. One is about Spark, if you know, then what it is, how it works, and second thing is how it is faster, how it is better comparing to MapReduce. So two things can be there which you have to take care. Any question here? No?
No, no.
Okay. What about you, Chandan? Are you there?
Yeah,
Any question?
noted.
I will ask the question. Not today, but someday. Because you
Okay.
are you all are saying that I am too good. Then if you are too good, then you should be good in responding as well. Right? It is okay, right, Naresh? Naresh and Pawan are
Yes.
there.
Yeah.
Okay. Okay, fine then. Be ready. I will be asking lots of questions from you. Just give me 1 minute. I am back. Okay. So we were discussing about Spark, right? Fine. So here about Spark architecture. Once you have understanding with the Spark, what it is, how it is working, how it is faster, how it is supporting you to process a good amount of data. So Spark is simply a processing engine which is supporting you to process huge amount of data with the time limit, with optimization, with parallelization in distributed model, which is making your task too much faster because it is having a functionality to work with caching and persisting model. So this is going to help you a lot in this. Now internally how this is working. So if we look at the Spark architecture, then this is again a master slave architecture just like Hadoop. In Hadoop you had HDFS and then MapReduce model for job tracker, task tracker, node managers and all. Right? You had name node, you had data node, name node was the master, and data node was the slave for storage and processing. Again, for storage also, means for HDFS, name node and data node. For MapReduce, you had task tracker and job tracker, which was working with in the master slave architecture. So here also it is following the same. It is having master slave architecture where master is called the driver and slaves are the worker nodes. If you are having some 10 node cluster, you can refer, okay, these are the worker nodes and this is the driver node from where this is getting operated. So when we run any of the Spark application, Spark driver creates a context and that is an entry point to our application. And all operations means transformation and actions are executed on the worker nodes and the resources are managed by the cluster manager. So here you have to understand the two things. One is driver and one is worker node. So you can have a driver node and there can be multiple worker node based upon the resources capacity you have provided. Like let's say 10 node cluster or 20 node cluster, whatever. Now, how they are getting communicated with each other. So Spark session is the entry point for any of the Spark application. If you are working with the Spark application, then this is going to have that session. Without creation of the session, this is not going to work with that. So previously we had a Spark context, SQL context and all, Hive context, SQL context, Spark context. But now with the means it was completely with the older versions. But then it got replaced with the Spark session and the Spark session binds with all Spark context, SQL context, Hive context and all. So you have to only initialize the Spark session and all the things will be available with this. You can utilize that. In some of the condition, exceptional condition, I can say you can create a Spark context with to work with some RDD model and you can do that. But again, not required with the Spark session. Of course, you can work with all the things. And then how it is going to connect. So there is the cluster manager here you can say. So this is the cluster manager. This cluster manager is making communication with their driver program and worker nodes because they are directly not good to communicate with them. Cluster manager is required who is taking care of each and everything, how the resource management is happening. Like this is the data, this is the code, this is the logic, and now you wanted to work with the worker node. So which worker node is having the capacity, which is not having the capacity, which is already running, which is having some issues and all. So likewise, this cluster manager manages all the resource management and with the driver program worker nodes connect accordingly. And then using this here you can see Spark context, right? So in previous models, Spark context was the entry point. Using that, connectivity will be happening and it will be working. It will be working on that to complete the entire process. But now you can replace it with the Spark session, and in Spark session, by default, Spark context will be available, and that will be working out. Then you have what you are doing, what you are working with this Spark. In Spark, we have lots of things to do, lots of requirements, business requirements will be there. And for that, we are performing two things. One is transformation and one is action. Transformation means, uh, let's say you are saying read the file. This is the transformation. Do filter. This is again one of the transformation. Do join, one transformation. Do kind of some uniqueness you are trying to filter. Then you are trying to do some manipulation. Let's say you are reading one of the column, and you are populating the data, some data to that column by some modification, or maybe doing some additional manipulation and all. These are not transformation. Finally, you call the action. Until unless you call up the any of the action, that will be in the lazy evaluation model. Means it will be taking the reference, but this is not going to actually work. Actually, it is not going to initialize that. And whenever you call the action in the sense, okay, give me first two lines of the file. So as soon as you are saying you wanted to read first two lines of the files, that means this is going to read the file. Without reading the file, this will not be able to give you the data, right? So now action will get triggered. So until unless actions are not triggered, it will be in the lazy mode, lazy evaluation. That's we can say lazy evaluation. That will be completely in the lazy mode, and as soon as we call the action, then it will be started reading all of the transformation. It will be doing go one by one for all of the transformation. If all are okay, it will be ending with the final result. If anyone is having any issue, then that will be failing with the particular exception or error, whatever. So you can say architecture wise, it is having some components, like one is the driver program, then you have worker nodes, then you have cluster manager. Cluster manager is the mediator which is managing between driver program and cluster worker nodes. Okay, this is taking care for the resource initialization and all, where which should be allocated and how it should be working. If any resources are struggling with one of the worker node, then how it will be working with another node, or maybe on the same node with another task. So all kind of management is coming from the cluster manager. Then it is having the initialization point, a Spark context. You can say Spark session. That is entry point. You can say for Spark application, your Spark will not be running without this Spark session. That is the main and first point. And then transformation and actions are there, which are the operations inside Spark. Because whatever you are going to work with this, whatever you are going to do, that will be ending up in the terms of transformations and actions only. Any question here? Okay. Then cluster manager. Cluster manager, here you can see one of the option, cluster manager, right? So cluster manager, you can have multiple, you can have varieties. Out of that, one is yarn, that is popular, and it is coming with Hadoop also. Then you have Apache Mesos, and then you have standalone. Standalone mostly we use for testing, where you can perform the testings and all. Okay, and then you have Kubernetes. So Kubernetes, this is an open source system for automating the deployment and scaling. And if you have any containerized application, then Kubernetes is going to help you. Then we have deployment mode in Spark. Okay. Deployment mode means how you are going to deploy your application. We have a Spark mode. Anyways, we will be discussing this in detail, that you can do with hyphen master, and then you can go with the yarn. Okay. This one master is the local. Here you can see local. Here you can see Spark. Here you can see yarn. Here you can see Mesos. So whenever you are having different resources, based upon the resources, you can choose how you are going to deploy with the Spark submit. And here is a local mode is for single machine, when you are working with single machine. And single machine means mostly your testing phase. You are doing the development, and step by step you are going to test that. Standalone mode, quick setup for multi-node clusters. Okay, and all these things are again coming for testing model only, not for the actual production. For production, you are going to use any of the others. Okay. Any question here?
No.
Fine. So here, as I was talking about this Spark architecture, so you can simply say it is having the driver program and worker nodes, right? So what is the rule for the driver program? Rule is the entry point for the Spark execution. And functionality wise, this coordinates the execution of the task and converts user code into a DAG, directed acyclic graph of stages and task. Here you can see the task, right? So this will be creating the DAG based upon the lineage model. Internally it will be having the lineage, then DAG, and then it will be having stages for the transformations, and finally it will be having the task. Task means that is the smallest unit of your data, and then interacts with the cluster manager to allocate the resources. This is the cluster manager. This is not going to directly communicate with the worker node that you are working over which are the task. Either this is going perfectly fine or it is having an issue or failure, then how it should run in case of failure, how it should do the recomputation and all. So driver program is not communicating directly. This interacts with the cluster manager to allocate the resources. Okay, resource cluster manager knows actually okay where the memory is available in which to which worker node this can be allocated, where it can work perfectly, and if in case of failures and all, again where it should be allocated. So all the things happens with the cluster manager. Okay, so in by Spark program, Spark session is created in the driver. So Spark session, here you can see Spark context. This will be created with the driver, and that will be the main point, entry point, and using that all the application will be completed. Then we have cluster manager. So cluster manager that is for managing the resources across the cluster. Across the cluster in the sense how many nodes you have. Then it can have standalone cluster that is built into Spark. You can have Yarn, that is Hadoop Resource Manager. Then you can have Mesos, that is General Purpose Cluster Manager, and you can have Kubernetes, that is containerized means container orchestration platform, you can say. Then finally you have executors. These are the worker nodes. Okay. So executor wise, this is the main place for the Spark where the actual works get done running on the cluster nodes. Okay, and it execute tasks assigned by the driver. Driver is going to assign the task. Cluster manager is going to take care for the resource allocation, and then finally worker node is going to work with the executors to complete all of the assigned tasks, and it stores intermediate and final result in memory or disk. In memory if that is fitable, if that is not fitable, that is going to persist with the disk. It communicates directly with the driver, okay, for processing. And then you have worker nodes. So worker nodes, physical machine in the cluster. How many physical machines we have, which is actually working on, and it hosts executors and perform computations on the data. So if you can see, this is the worker node. So this is the actual physical machine over the cluster, and on top of this means over this actual machine, executors is available. So it is hosting the executor. Okay, and then this executor is going to complete your task. So this host executors and perform all the required computation over the data to complete the application. Then we have a Spark session. Spark session, it is the unified entry point for all of the Spark functionalities, and it manages the configuration, and it provides access to Spark SQL, DataFrame API, and other libraries. Many more libraries are there. Okay, so this is having four parts, three parts mainly. One is driver, one is cluster manager, and then you have executor. Executor is getting hosted by the worker nodes. Worker node is the physical memory. This is managing all of the resources, and this is the main Master, you can say, for the entire Spark cluster resources and Spark context, or you can replace with the Spark session. That is the entry point for the entire application to get run and process and complete, and that will be with the driver node. When we talk about execution flow, how internally it works, then first driver initialization happens. Where let's say we are submitting any of the job, any of the data. Then uh, user submits an application to the driver program, a very first step. Then driver converts the application code into the tag. So user is submitting the application at the very first step that this is what I need to do. Then as soon as that submission is happening, driver is converting that application code to a tag. Then job submission will be happening internally in the actual form. DAG will be divided into the smaller stages because there maybe whenever you are submitting the job, you have application, nice application you have developed, and there are lots of transformations are there. Based upon each of the transformation, there will be the category, and for each one, there will be the stages. Stage will get created. So DAG will be divided into smaller stages, and each stage will be containing few tasks. Here you can see task 1, task 2, again task 1, task 2, multiple tasks will be there. So task is the smallest unit of your data, of your job. Okay. So as soon as user is submitting the application, driver will be accepting that and then converting that application code into the DAG, and then further DAG is getting divided into smaller stages, and that stages will be containing the task. You may get confused here, don't worry, we will discuss that again in detail. And tasks are distributed to executors in the cluster manager. Then we have task execution. For that, executor process tasks on the data partitions, and data is processed in memory to optimize the performance. That is making it faster and flexible. And then result collection. Finally, once your DAG is done, staging is done, tasks are there, task gets distributed over the worker nodes and executors, and processing is happening. Then finally result collection will be happening at the end. So result from the tasks are sent back to the driver. Okay. And driver aggregates and provides the final output. Then in Spark, we have three core abstraction. One is RDD, one is DataFrame, and one is Dataset. If I talk about RDD, then in very short, I can say this is immutable distributed collection of data. So full form of RDD is resilient distributed dataset. And that is immutable in nature, distributed collection of data, which is helping to enable the parallelism and process your job in a faster manner, and supports fault tolerant through the lineage. Internally, this is going to work with lineage, so this does the data recovery from there. Then data frame. Data frame is the distributed collection of data organized into named columns. If you have the data and you want to convert that into the structure of like a tabular format with the row and columns with naming columns, then data frame is an option for you. You can do that. You can convert your data into data frame, and that will be completely like a tabular format. So this is the distributed collection of data organized into named columns and optimized execution using Catalyst Optimizer. Catalyst Optimizer means you are not going to do anything. You are not going to write any additional code for this. It is optimized. In backend, the Catalyst Optimizer is enabled with the data frame. If you are using that, this is coming to you by default. And that is making your job faster. Then dataset. Anyways, dataset is not the part of PySpark, but you should know this because you should understand what is dataset and how it works. Today, maybe you are working with PySpark, that is fine. Tomorrow, you can have the requirement change and you may get the requirement to work with Java or Scala. Then that is one thing. And second thing, We don't know, maybe tomorrow dataset also get introduced with the PySpark, then you have to work here as well. But we can say that as this is the part of core abstraction of the Spark, then you should know about it. Either this is getting supported in Python or not, PySpark or not, doesn't matter. So for dataset, this each combines the benefit of RDDs and data frame. RDD is having its own pros and cons, data frame is having its own pros and cons, and data frame is having its own. So the thing is, when first in PySpark we have RDD and data frame support. Both is having, and in if we talk about Scala, then we have data frame, data sets, and RDD, all three. So this data set is the combination, and I can say combining the benefits of RDDs and data frame both at a single place, and that is coming with data set. Here in PySpark, dataset is not there because almost all of the functionalities they have enabled with data frame only. So whatever you can achieve with the datasets, simply you can achieve the same with data frame also. So that is the combination of both RDD and data frame, and it is strongly typed, enabling compile time type checking. Okay, and lots of another libraries are there with the Spark while you are working with either data frame datasets or RDD with the Spark SQL, which is good for structured data processing. You have Spark streaming whenever you have requirement for real-time stream processing. You have machine learning library, which we say MLib, which you can use for machine learning. You have graphics for graph kind of processing. Okay, so these are some things where you can explain this, and you can simply say if something is coming about a Spark architecture, of course, this will be the part of your interview. Question can be there. Explain me about a Spark architecture. Then you can start with the driver program, then worker nodes, executors, cluster manager, Spark session, DAGs. Anyways, DAGs, lineage models, and all we are going to discuss with our session, next session. Okay, but you can keep in mind all that things, how job submission is happening, after that how resource management is happening with the cluster manager, then how executors are taking care for the stages and job task, and processing is getting completed. So all these things you should keep in mind. So you can say for the driver program, this is defining the logic, then cluster manager, this is allocating the resources, executors, this is processing the data partitions in parallelism, and finally result gets collected to the driver from the executors and write them to the destination. Your target can be either file or database or maybe something else, some other in between data pipeline. There you can write the data. So likewise, your Spark architecture is defined internally, and how this is working. I hope it is fine. You will have access for this document, okay, and you can go through it. Here I have mentioned again for the key component of the Spark architecture with the driver program, where this is helping you to scheduling the task and monitoring their execution, collecting results from the task, and managing the cluster resources. For cluster manager, this is helping you to managing the resources across the cluster, where it is having the option which cluster manager is configured. Either it is Yarn, Mesos, Spark, or maybe something else like Kubernetes and all. It supports for allocating resources to Spark applications and monitoring the cluster and resource usage. Then you have executors, which is helping executors are the worker nodes that runs the actual task and return result to the driver. And each executor is responsible for executing a set of tasks and storing data for the application. Where this is doing its responsibility by running computations as assigned by the driver and caching data in memory for faster access during the job execution. Then finally you have the task, that is the last option. Last option means the smallest unit for the data which is actually getting processed. So a task is a smallest unit of work in Spark, and each task process a partition of data. Partition of data means, let's say you are having a 10 partition for the data and each partition is of 1 GB. So maybe that is again divided into a task based upon the internal block sizes. And the driver schedules task based upon the DAG generated from the job, because driver is completely going to work with DAG only. Then already we discussed about this RDD and data frame and data set, where RDDs are the fundamental data structure of Spark, representing an immutable distributed collection of objects that can be processed in parallel. And then RDDs can be created from existing data or transforming other RDDs. So I have a question here. Can we manipulate the same RDD? Can we make the changes? Anyone can reply. No answer from anyone? Naresh, you tell me.
What is the question, Anamika?
Question is, can we modify the data in RDD?
This is immutable, na?
No, I am asking you.
uh,
Can we or we can't? Can we manipulate the data?
we cannot manipulate the data. I think it will create another one with the reference.
Right. It will be returning the new RDD, but it can't do the changes over the same existed
It's
one.
similar to string, Python string, we can say.
Right, right. So here the same I have mentioned, representing an immutable distributed collection of objects that can be processed in parallel, and you can do the changes that will be returning a new RDD, but it can't modify the same existed RDD. And RDD can be created from existing data by transforming other RDD. Let's say you have a data with 10 columns. You read the data from the file. Now you want to add 2 more columns. You can have RDD2 and you can add the columns. Again, in RDD3, you can remove the existing few columns, 1, 2, 3, 4, whatever you want. So you can do that. You can make the changes, but only condition is this will be returning a new one and it will not be modifying the existed one. And then from the data frame and data sets. So these are the higher level abstraction built on RDDs. And it is allowing for faster manipulation of structured data. And main thing is you are going to work with the tabular model. So tabular format of the data means it is increasing the readability. You will be good to understand the data, right? And once you are good to understand, then you will be good to do a lot of things, whatever is the required, because you have the named columns. You know, okay, this is the column, this is the type of data for this is the data type, and what you really need on top of this, so you can perform that. So for data frame, this is a high level abstraction built on RDD, and that allow faster manipulation over the structured data. And for dataset, this is the combined benefits of RDD and data frame both, providing strong typing and ability to use both functional and relational operations. And again, this is not available in Python, PySpark. Then execution flow. About this execution flow, simply I'm going to repeat whatever we discussed previously. So when you have user code, then the creation, then task scheduling, then execution, and then final collection. This is in the sequence how your uh, Spark application is going to work in backend. First, you are submitting a Spark application with any of the API. Once you submit it and that is accepted by the resource manager, then the creation will be happening. Okay. So first, let's say some issue, then your job submission will not happen. One that is submitted, then you are going to get one of the application ID, and as soon as you get, then it will be starting the processing part. Very first driver program work starts with the Spark session. It is going to create the Spark session at the entry point, and then this will be converting the user code into a logical plan, and then the DAG of execution, because this is going to process the entire code base in the terms of DAGs. Okay, and for processing the entire application, this needs a entry point, the Spark session, and with that Spark session, the entire processing will be application processing will get completed. So as soon as user is submitting the Spark application, driver program converts that user code into the logical plan and go with the DAGs to execute the entire task. Then task scheduling. Driver schedules the task for each stage. Stages will be there for the DAG, and based upon the data locality and resource availability, it is going to schedule the task. Then execution will be the next part of your architecture, where this will get executed with the executors. Like executors are going to run the scheduled task on the respective data partitions and processing data in parallel. And finally, once all the processing is done, this is the time to get the output and then result collection. Then once task is completed, then result will be sent back to the driver for further processing or output. Let's say you have 1 GB file. That 1 GB file is working with some 100 tasks and with the 10 executors. Then all worked separately. They have generated their own piece of output. And finally, we are going to write the output at the destination, at the target location. Then we need all data together, right? So that time this data is moving back to the driver for further processing or output. So you have to focus on these main things: driver program, then cluster manager, executors, RDDs, data frames, and data sets. Question will be about our Spark architecture. It can be a simple question. If you can explain Spark architecture, you have to explain that, where you have to include about your driver, cluster, worker nodes, Spark session, resource manager, and all. Then RDDs, data frames, and data set. This is a very common question for any of the interview you are going to face. Question can be what is RDD, what is data frame, what is data set, what is difference between data frame and the data set, or difference amongst all three RDDs, data frame, and data sets. So you have to answer accordingly. So you should have understanding because these are very common question, and it can come to your it can be part of your interview. Okay, maybe I'm not sure even if you have already attended any interview or not with this Spark, and if you have attended, then you have faced this question or not. But most probably these questions will be part of your discussion. Anyone has faced this question? If you have tried any time for the Spark interview? No. Okay. Yeah, someone was about to say something.
No, that question.
Okay, fine then. uh it is about this one, and then you can focus over the Spark installation part. Okay, you can here also I have mentioned the steps how you can do, and if you want you can take some other references as well, and you can do the installation. You can set up in your system so we can run that, and even for testing purpose, for standalone mode, you can run with the Databricks Community Edition also. Without any installation, you can work on. Only thing is you will not be able to integrate with the other tools like database, Kafka, MongoDB, and all. That is only drawback. Otherwise, you will be good to have the exercises. So try to do the setups and all. Okay. Then we will move next with the hands-on session where we will be discussing in details about DAGs, lineage, tasks, stages, and all. Okay,
So whenever
fine.
can we see those things basically when we're will be submitting a job,
how in the back end how this is working. So basically those things are.
Of course, you can see if you are if you are setting up in your local, then also you can go to the host and you can browse that. Or if you're working with the Databricks, then Databricks also you can debug that while you are going to checking the job, what is happening. Then it will be showing you the DAG. This is the DAG. This is the stages. These are the tasks. You will be getting all the things.
Sure. Okay, I've done the local setup. I'll also create an account in community edition. Yeah, thank you.
Yes, sure, sure. Okay. Then let's meet tomorrow. Have a good day. Bye.
Thank you.